Hi, and welcome back to another video. So about few weeks ago, myself and my team were in Kumasi, and Kwadaso to be precise, and I must say Kwadaso has got some really nice building, very beautiful buildings, and some are very huge. Yes, big mansions in Kwadaso. Yeah, the community we actually found ourselves was an estate, and it had really nice projects going on over there. So we were there to have a solar system installed, and this system, it's not the usual ones you've seen me share, although we've done something similar to this in the past. I hadn't really shared that yet. So this was a high voltage system that we worked on. So you may ask, what is a high voltage system? So I'll explain a little bit about that shortly. But the system, or the capacity of the system we installed, was 30 kilowatts. So the panel size was 30 kilowatts. And then the inverter was also 30 kilowatts. And then the battery was 64 kilowatt hours. That was the capacity of the system that we worked on. So back to high voltage system. So with solar systems, there are different voltages. So you can have a 12 voltage system, which would be like for a very basic setup that would need basic appliances, be it inverter, panels, as well as the battery. Then you have a 24 volt system. So my very first solar project was a 24 volt system, and that was what we installed for our one bedroom house. That was some time back. Yeah, so you can have a 24 volt system, which is also for basic like appliances, like a small unit among others. Then you can have a 36 volt system, which is also there. Then you have the 48 volt system. So a lot of the videos on my channel are the 48 volt system or 51.2. So that one also works within a voltage range. So between 48 to about 51.2, that is basically the voltage range for such system. And we also have the high voltage. So the high voltage can be double of the 48 volts, can be 3 times, can be 4 times, among others. Can go on and on and on. I'm sure you may ask, in what circumstance will one need or require high voltage system? So high voltage system is usually used for bigger projects, like bigger establishments like factories, hospitals, schools, because then for such establishment will require bigger size, power, high demand power to be able to power the operations or their system. Then you may ask, okay, why then did we install a high voltage system for this particular house? So the first thing is the house is quite a big house. It has got quite a number of air conditioners alongside other appliances. Although the 48 volt system or 51.2 volt system would have worked, the owner chose to go with a high voltage system. And in this case, the owner had already purchased all the equipment that we needed for the installation. We were just called in to carry out the installation. So yeah, that is why the high voltage system. And it's not bad because, like I said, quite a number of air conditioners, other appliances that are going to be used in the house. So now let's look at the different components of the system. So the panels, the inverter, as well as the battery. So starting off with the panels, just as I said, 30 kilowatt capacity panels, and each panel size is 720 watts, and this panels is a bifacial monocrystalline panels. Yes, so bifacial means that you're able to generate power from both the front side as well as the back side of it. Now, if you take a good close look at the roof, you notice that the color is white. So just as we did or we had done in the farm some time back, which had its original roof color painted from, I think, wine to white, the same way for this house. And I must say it was actually the same owner we worked for at the farm. So he had the roof also painted from its original color to white, so as to be able to maximize the use of the panel. So we went ahead to install the panels using the same accessories we used at the farm. So the L-foot with two different points where you can mount the rail to. So we used the high point, and then also we had the clamps for the earthing or grounding. Yeah, so we also did that. So the panel was installed a little bit elevated above the roof, so then once light bounces on the white surface, it's able to bounce at the back of the panel to also help generate energy from that side as well. So actually maximizing both the front as well as the back part. Now the total capacity 30 kilowatts comprises of 41 pieces of the 720 watt panels, and we had 3 arrays out of it. So we had 14 pieces, 2 arrays of the 14 pieces, and then we had 1 array of 13 pieces of the panel. So this also boils back to the high voltage system I was talking about. So for this, we had between 580 to about 680, they're about close to 700 volts from the panel, so from different each array. So for the 13 pieces, or the array with the 13 pieces of panel was generating around 580 volts thereabout, and then that of the 14 was generating between 6 something to close to 700 volts. Now when you look at such a system, there are quite a number of things that you have to take into consideration. So the kind of cables that you are using, because it's a high voltage system, the kind of MC4 connectors or accessories that you are using also is very important, because there are some MC4 connectors that can carry up to about 500 volts or 550 or 600. There are some that can carry up to 1000 volts among others. So for the system, all these things were things we took into consideration. So that was done. So we took quite a number of days to install the panels. You can look at the height of the building. These are 3 floors. So yeah, we had to first get all the panels to the top, and the next point was to have the panels also installed. So it was quite work. It took about between 3 to, I think, about 4 to 5 days to have all the panels installed. So we started off by mounting the rails, and even with that, we had to be a little bit more strategic so as to be able to fit the panels, because if you don't orient them well, you could finish and then you don't get the total quantity of panels that you're able to fit in there. So it was quite some work, but we had that done. Then we routed the cables through a pipe. So initially there wasn't plans for having solar system, so they didn't make provision for conduit pipe to the top. So since now that is going to be the case, they had to cut the wall, pass the pipe, and then we had to pass our cables through it. For such a system, it's very important to ground it, as well as in case there's any excessive power, whatever it is, it doesn't provide or cause electric shocks. And this happens usually on a lot of systems. If you don't ground the panels, you can experience electric shock, especially if it's alu-zinc or metal roofing sheets. Yeah, so we had that done. And then also looking at the height of the building, so the cables had to come all the way down, and then from that point go all the way through to the power room, which was close to the gate. So it's quite a distance. So I'm sure somebody may ask, okay, in this case, are we not going to lose some of the power, just as somebody asked for the farm? So in this case, doing all the calculation, factoring the size of the cable, the MC4 connectors among others, and then the distance, the amount of power we're going to lose was very insignificant, 0.016%, and that is really insignificant on the system. So all these things were taken into consideration. So that's on the side of the panels. 41 pieces bifacial 720 watt bifacial monocrystalline panels. So that was installed. Now let's move on to the inverter itself. So just as I mentioned earlier, this was 30 kilowatt Deye inverter, and Deye happens to be one of the best brands out there, just as SRNE. Deye is also a very good brand out there when it comes to solar systems. So yeah, this is a high voltage inverter. So then the voltage range is quite higher than the normal 48 volt inverter. So the PV input was voltage was the maximum is 1000 volts, but the input range is between 150 volts to about 850 volts. So then the voltage that we got from the panels falls within this range, so it's good. And also the inverter has 3 MPPT charge controllers. So then the 3 arrays we had from the roof or the panels, goes to each MPPT charge controller. And I think each inverter or each MPPT has 2 strings to it. So because we are doing, 3 arrays, we just, matched each array to each MPPT charge controller. So that's for the PV side. Also, when you are working with high voltage system, it means that the surge protecting devices or the isolators you are using will also have to match the voltage range. For this, we had to use 32 amps, 1000 volts. Yes, so the breakers are able to carry up to a maximum of 1000 volts, the same as the SPD. The SPD was also 1000 volts, so as it matches the system. Else, if you are using something below, you're basically, already introducing problem to the system. So that was some of the things we had to take into consideration. So aside the panels, the cable size, the MC4 connectors, also you look at the breakers or isolators, also you look at the SPD. So that was done. Then come to the inverter, matching each MPPT charge controller. Then aside from that, also we look at the battery capacity, because it's a high voltage system. The battery voltage range is between, I think, minimum point is between 20 volts and above. So in this case, we had 64 kilowatts. It's a high voltage system. This is a stack or the rack type of batteries. They are stacked on top of each other. So we had 4 pieces of that. Each battery is 16 kilowatt and the voltage is 51.2. So the batteries were connected in series. Yes. So ideally, for a normal voltage 48 volts would have done it in parallel, but in this case, since it's a high voltage system, we need a high volt, so we connected them in series, giving us about 204 volts thereabout, so as it's able to meet the minimum requirement of the inverter, because the inverter minimum requirement was 200 volts and it was between 200 to about 1000 volts. So that was on the side of the battery. So I'm sure some people may ask, isn't it of concern, especially the size of this room, ventilation among others? So that is how come this type of door is being used, so as to allow air into the space, take out or extract any form of heat which is going to be in there. So this is okay. There's also a little window which is behind in there that is equally going to help with ventilation. So the battery comes in different points. So there's the battery itself, and then the master control unit, which is at the very base of the battery. So all the batteries are connected in series and then connected to it, and then you connect the inverter to that point. So that's where you turn it on, and then you also connect the BMS cable from that point to the inverter. Now aside that, also let's take some critical look at the inverter. So the inverter was a 3-phase inverter. So in solar system, you have the single phase as well as the 3-phase. So single phase would be for like smaller homes, and then 3-phase would be for bigger homes or bigger places among others. So in this case, you have 4 different lines. You have 1 serving as neutral, and then you have line 1, line 2, line 3. Now, because it's a 30 kilowatt system, each line is taking about 10 kilowatt. And in this case, also, you're able to either reduce the capacity of each line and then maybe increase the capacity of the other line. So that's one good thing I like about such system, because if you have more load requirement on a specific line, you're able to increase the capacity of that line, whereas you decrease the capacity of one of the lines. So this was inverter was a 3-phase inverter. So then the configuration is done in such a way that the panels to the SPDs and the breakers, and then from there point to the inverter, then from the batteries also to the inverter, then from the inverter output with 4 lines also going to the ATS. So I'll talk a little bit about the ATS you see in this video. Yeah, I'll talk a little bit about it. So that was basically the system. Now when you look inside the inverter itself, you notice that we have some magnetic rings in there, and this actually has a purpose that is served. So because this is a high voltage system, as part of its production, it generates some form of noise. Now, in order as to prevent the noise from being part of the power that is generated or transmitted, there's the need to put this magnetic rings around them. Now, these rings have ways you have to even go about installing them, and this is basically to prevent or stop electromagnetic interference, or RFI, radio frequency interference, from as part of the power. And these can have effect on some of the systems that are used, like radios, TVs, among others. These can have effect on such systems. So for this project, yes, it all came as part of the system, and this is why it is very good to read manuals for every system that you install, because no system is the same. Although you might have even installed the same thing, there could be a case where there's just a software update or upgrade, and this I have actually encountered a couple of times. There could be just a software update which will have some features that maybe the previous one I did install didn't have in it. So I always tell my people that whenever you are working on such projects, always try possible ways to go through the manual. Although you may know it already, but it hasn't hurt to still go through the manual, so you'll be able to identify or find something new, and then you're able to implement it. So we had those rings installed, and then you can see some clamps also on each of the lines. So those are CTs, current transformers, and the work of that is also to prevent sort of backflow of power back to the grid, or in case you don't want to sell. So in some part of the world, you're able to sell the excess power you generate from your solar system to the grid or the electricity company. In our case, although I've heard some rumors that we are going to have something, in that line also implemented, and outside of, I think, the government has started something, but I don't know how that is really going. So in case you want to sell excessive power or excess power from your system, you're able to do that. But the purpose of the CT is either to prevent that from happening, because some of these systems, if you don't configure them properly, you can generate excess power and then it can be going back to the grid, which is even going to affect your meter reading, and that could even bring you a higher bill. So the CTs are also important, and you can see that they are installed on each line of the inverter. I must say that that is not the final position of the CTs. So the CTs are supposed to be between the grid and then the home load. As it stays now, the grid hasn't been connected to the house yet, so that is how come we've temporarily placed them in the inverter, so that once the grid is connected, then we can position them or place them where they are supposed to be. Now let's talk about the ATS. So what you see there, that big box over there, is an ATS. And what is an ATS? ATS is simply an automatic transfer switch, and that is able to allow you to change different source of energy. So if you have power coming from, let's say, the grid, power coming from a generator, power coming from solar system, you're able to switch between those mode of powers that you have available. Now this particular one we see there is a Ghanaian manufactured assembled ATS, and basically what they've done is they've put together contactors. So we have contactors that are used for different purposes, so they put them together to be able to form like an ATS, automatic transfer switch. However, the challenge with this system is that the contactors are 3-pole contactors, and a normal ATS or 3-phase ATS would have 4-pole, and in our case we required 4-pole. In this case they had 3-pole, and the challenge with this is that you have line 1, line 2, line 3. However, you don't have any slot for the neutral on the contactor. So in that case, it means that whatever power is coming from the grid, aside the lines, the neutral line is going to have direct interface with that of the solar system, and that is really, really bad, or not right, because some of the challenges I've had with our grid companies, that there are instances where line 1, line 2, line 3, they swap the positions, and it affects. So I explained this when we're working on our project Agbawi, where today you connect the lines, they work correctly. Tomorrow you have an error on the inverter, and basically it's telling you a phase error, and it's just basically they've swapped the lines. And I've even encountered a situation whereby there was short circuit on the side of the electricity or the grid company. So it means that there could even be a case where the neutral line is swapped with a live line, and that brings power, and that goes directly to the inverter, and that's not right. So I actually spoke with the owner about that no, we can't use this ATS, and requested for them to replace that with an already manufactured ATS, because an already manufactured ATS has 4 poles. If it's 3-phase, it has 4 lines, or 4 lines. So you have line 1, line 2, line 3, and then neutral. All this is built in as part of the ATS. You don't have any of the power source interfacing or interfering directly with another power source. No, it's not the case. Maybe the only downside will be with some of these ATS that it only has 2 power sources. So if it's grid and solar. If it is grid and generator. If it's generator and solar, you can have. I haven't really come by the ones that you can have. I'm sure there should be, because you should have a situation where you can have different power sources and you're able to use that. But the ones that I've really come by here, the ones with 2 power sources. And in this case, the owner was not going to be using a generator, so there's not even a point for the locally manufactured one. So I requested for that to be changed, and as at the time we're living, it wasn't changed. But as it stays now, that has been changed, and that would help the system work well, because when you compare the cost of the whole solar system setup as against that of the ATS comes nowhere close to the cost of the inverter. So there's no justification for wanting to still use that ATS. Although when I mentioned to the electrician, he was trying to convince us to use, but I insisted that we can't use that, because it's one thing about the project we take care of is that when we notice something is wrong, either we talk about it. If we can do something about it, we do something about it. Because one thing I've realized is that a lot of homes, like I mentioned some time back, has serious electrical problems. Recently, one that we encountered at 30kW Deye, there was earth leakage, and basically it was current flowing through the earth, and it was giving an inverter, it was flagging the inverter with so many errors. So we eventually had to bury our own earth. Yeah, but that problem was not resolved. So what happened was that when we were buying prepaid or buying electricity, some was basically going to the ground, and you keep buying and buying. So we pointed out to them that we actually solved part of it, and it reduced whatever current that was flowing through it, but we weren't able to solve it at the time, because that wasn't what we're there for. And the reason why I point this out is that sometimes some people homes will already have existing problems. We didn't know about it. Now once you come to install your solar system, then all they say is that when the solar people came, then this problem started coming there about, you get it. And that's usually that's how some people would see it, rather than tackling the problem. So whenever we come by challenge, we try to talk about it or do something about it, so that it makes the whole system effective, works very, very well. So in this case, we spoke about it, and that has been changed. So yeah, we had the system configured. Now also for the side of the battery, usually the DC battery breaker would have used would be around 500 volts or 500 VDC. But in this case, it was 1000 volts, so 250 amps, 1000 volts, very, very necessary, because we are dealing with a high voltage system. So these were some of the basic things that for such systems, it's very important to pay attention to the kind of voltage you are dealing with, the kind of amperage you are dealing with, so you know how to size your cables. So even for this, the output cable from the inverter to the ATS was 25 millimeter cable, so it was also an armored cable that was used. So yeah, very tough cable, so as it's able to carry a lot of energy or power to be able to serve the house. So in a nutshell, it was a smooth and successful project. We took quite a number of, I think about 2 to 3 days also to install the inverter, because we had limited space to work with, and the inverter is very huge. If you look at it, it's quite big. Yeah, I can't really recall the size, but it was huge. And then also the batteries are super heavy. Yeah, the rack for it, stacking them in the rack, as well as doing the configurations, earthing. And then also another important thing was also to earth the battery. Yeah, it is also very, because you're working on high voltage system, it's very, very important. Grounding is very important, and such and stuff. So in a nutshell, it was a smooth and a successful project. We finished, we tested everything was working really well. And one thing about this inverter is that it's not really a sophisticated inverter in terms of the configuration. It's just straightforward configurations. You don't have to really do much, as against some other inverters where you have to do so much in terms of you have to do this, you have to, this was Deye inverter. This particular Deye inverter was quite a smooth one. It was a straightforward one. It did all the necessary configurations, and we're good to go. So yeah, that was how solar project at Kumasi, Kwadaso to be precise, went. And in case you are wondering if we take our projects in other parts of the country, yes, we do. So we go as far as Tamale, the northern parts, the western region. Yeah, we are soon to work on a project in the western region, which we'll be doing very soon. There's Ashanti, so almost every part of the country. Once, we can get transportation there, you can get your materials there, we definitely will be there to carry out the installation for you. And one thing I'll say is that it is when you're considering a solar system, although you may want to even buy or ship the items from China or wherever it may be, I think it's very necessary to consult a solar expert to be able to discuss your requirements, so as you size the system effectively. I'm saying this because there was a project we worked on. I'm not going to give so much details about it, but the system was bought, and at some point there were some challenges because those who were responsible for sizing the system didn't really size the system properly, and this in this case was the supplier of the equipment, and then there was some challenges about that. So if you're going to even buy, although maybe the price may be cheaper, you can look at that. Aside that, also, just as I do sometimes advocate for, is that if you have the means and you have the will, maybe you should buy from here, because when you buy from here and you have challenges with the system, it can be resolved for you. Of course, the system from out there may also have warranties, but is it a case where when there's a challenge, you're going to ship the system back to wherever it came from for them to replace or have a look at it? And I'm sure that is going to be costly. If it's cheap, it's going to be cheap for you, then that is totally fine. So that is just about it for this project. You can drop your questions, your concerns, your comments, whatever it may be in the comment section, and I'll do all to respond to them. So thank you very much for watching, and I'll see you in the next one.